Today we're talking about parallelogram properties. Now, first of all, you need to know what a parallelogram is. Here's an example of a parallelogram. It will not always be this exact same shape, but there are certain properties that tell us whether we have a parallelogram or not. The first property we're going to talk about today is that parallelograms have two sets of congruent sides. We're going to say that the opposite sides are congruent, right? If you think about it, a rectangle and a square are both parallelograms because the opposite sides in a rectangle or a square are congruent. We also have opposite angles that are congruent. Now, if I take a look at the purple and the red angle, those are what we call consecutive angles because they're kind of side by side, not quite adjacent, but they're not across from each other either. To talk about opposite angles, I have to go all the way in a diagonal motion across the shape. So opposite angles are also congruent. By the way, in a parallelogram, this is kind of a side note, like all four-sided shapes, the interior angles are always going to add up to 360 degrees. In a three-sided shape, our triangles, it was 180, but in a four-sided shape, it's 360 degrees. So here's my parallelogram. Here's my symbol for parallelogram ABCD. Now, I need to name the parallelogram, I need to use all four vertices, and whichever one I start with, I need to go clockwise around the parallelogram. So ABCD could also be named BCDA, or if I started with C, CDAB, or DABC, right? But in a parallelogram, you use all four vertices, and this is the symbol. So if this is absolutely a parallelogram, no questions asked, then AD is going to be congruent to BC. Those are opposite sides. And AB is going to be congruent to DC. I can't only check one pair of sides to see if they're congruent. I have to check both. Angles A and C are going to be congruent to one another, as well as angles B and D. So opposite angles are going to be congruent. There's one more super important feature of a parallelogram, and this is why it's called a parallelogram, is that I also have opposite sides that are parallel to one another. So AB is going to be parallel to DC, and AD is going to be parallel to BC. If I don't have two pairs of parallel sides, I don't have a parallelogram. And one last thing, if I draw a line segment from corner to its opposite corner, I create segments called diagonals. They're called diagonals, of course, because they go diagonally across my shape. Diagonals do something extremely significant when I have a parallelogram. They bisect each other. Now, bisect means to split into two equal portions. So both diagonals have been split into two congruent segments. That also means that the midpoint, or this point in the middle, is the midpoint of both diagonals. That's going to be significant in just a few minutes. Let's take a look at what we can do with some of this information. Let's say that we have a quadrilateral. Quadrilateral simply means four-sided shape, and it gives us the four vertices. But not just that, it's going to ask us if this quadrilateral is a parallelogram. Now, for me to prove that this shape is a parallelogram, there's three ways that I can basically figure this out and show my proof. The first way is to use distance formula on all four sides to tell if I have opposite sides that are congruent. I can also use slope on all four sides to see if opposite sides are parallel. The third and final way that we're going to go over today is to use the midpoint formula to verify that diagonals do bisect each other. We're going to take a look at these one at a time. We're not going to try all three at once, of course. We're going to start off with using distance formula to tell if our opposite sides are congruent. So I'm going to draw a little picture. I'm not going to take the time to put this on a coordinate grid. If I have vertices A, B, C, and D, I can put them on a coordinate grid, but just the look of the parallelogram isn't going to give us a whole lot of information. So I'm going to basically just draw a random picture and use these vertices to help me out. First of all, I need to find the distance or length of all four sides. If this is going to be a parallelogram, then the length of AB should equal the length of DC, and the length of AD should equal the length of BC. So let's use distance formula to help us find length. I'm going to work under the assumption that you know how to use distance formula. If you don't, that's a different video. You'll need to watch that first. So if I do the length or distance from A to B, that'll give me the length of AB, right? If I plug that into distance formula, I get the square root of 52. There's no reason to change this into a decimal or simplify that any further, because if I get another square root of 52, I know it's congruent. Next, I'm going to find the length of DC. Putting D and C into my distance formula, I get square root of 52. So I can see just from distance formula that AB and DC are congruent. If I use distance formula on A and D, I get square root of 17. And finally on BC, I get another square root of 17. Looking at the first two, AB and DC, we see that they're congruent. Looking at the last two, AD and BC, I can see that they are also congruent. Hence, I have opposite sides that are congruent, and I can say without a shadow of a doubt that this shape is a parallelogram. Pause the video if you need more time writing these notes down. Let's move on to method number 2, or proof number 2, using slope to tell if opposite sides are parallel. Again, I'm going to write a little just kind of picture so that I know which sides are actually opposite. And then I'm going to start using slope formula this time to tell if I have parallel lines or not. AB should be parallel to DC and AD should be parallel to BC in this picture. So if I find the slope of AB, again I'm working under the assumption that you know how to find slope. If you don't, that's another video. Slope of AB turns out to be 2/3. Slope of DC is also 2/3, and if my two slopes are the same, I know that those two sides are parallel. Remember, one pair of parallel sides is not enough. One pair of parallel sides could be a trapezoid, so I've got to check both. So I'm going to find the slope of AD and the slope of BC. I can see that my first two opposite sides are parallel because they have the same slope. And now I can tell that my second pair of sides are parallel because they also have the same slope. Like I said, this picture is not to scale, nor did I put this on a coordinate grid. So don't worry about that my -4 slope isn't actually a -4 slope in my picture. We'll be okay. And since I have both pairs of opposite sides that are parallel to one another, this shape is definitely a parallelogram. Pause the video if you need more time to take these notes. And finally, let's move on to method number 3. Let's use the midpoint formula to verify that the diagonals bisect each other. Remember in our first picture, my diagonals, right, shared the same midpoint. It has to be exactly the same point. I'm going to draw in my diagonals, and I can see that my diagonals go from D to B and from A to C. So I'm going to find the midpoint of AC and again the midpoint of BD. If I put A and C into my midpoint formula, again, we're running under the assumption that you know how to do midpoint. I get the point -1/2, 4. Then I also want to do midpoint between B and D, and I get the exact same point, -1/2, 4. Since those two midpoints are exactly the same point, that means that my diagonals absolutely bisect each other, and this shape is a parallelogram. If any of these three methods showed you slopes that were not the same, or midpoints that were not the same, or distances, otherwise known as lengths, that are not the same, you could show that these shapes are not parallelograms. I'm just taking you through examples that are. One last example for today. Let's take a look at some angles. I want to find the values of x, y, and z in parallelogram ABCD. Notice it's already telling us it's a parallelogram, so we already have some information about this shape. First of all, I know that opposite angles are congruent. So let's work on that assumption first. Since the only angle I know anything about truly is angle C, I'm going to use angle C first of all to help me find y. Since opposite angles are congruent, angles A and C have to have exactly the same measure. So I'm going to set 5y equal to 130. Dividing both sides by 5, I get y equals 26, and I've already solved for one of my three variables. Now, in a four-sided shape, in any four-sided shape, consecutive angles are supplementary. Since 130 degrees doesn't have any other opposite angles, I can use the fact that consecutive angles add to 180 degrees. I don't want to use the fact that I found y to be equal to 26 because if I had calculated that incorrectly, then x and z would also be incorrect. So let's take the fact that if I add the measure of angle C to the measure of angle D, those are going to add up to 180 degrees. I'm going to plug in or substitute in 130 for angle C and 2x for angle D. Subtracting 130 from both sides, I get 2x equals 50, which then is going to show me that x is equal to 25. And now I have 2 out of my 3 variables. Since I don't want to use x or y to find z, because I calculated x and y, and if I made a mistake, that would affect my measure of z, right? Let's use again the fact that consecutive angles that are kind of side by side, are going to add up to 180. So the measure of angle C added to the measure of angle B is going to equal 180 degrees. So I'm going to put in Z for angle B and 130 for angle C. And subtracting both sides by 130, I get Z is equal to 50. Now I've solved for all three variables. I think it would be wise of you to plug those back in and make sure that all 4 angles add to 360, just to verify your answers and to double check before you turn in your assignments. All right, I think that's plenty for today. Make sure you bring any questions that you have to class. I hope your day is fantastic, and I'll see you next time.